سلام الله عليكم طلاب مبادئ الإحصاء، إن شاء الله يا رب تكونوا بخير وأموركم طيبة إن شاء الله. خلصنا الفيديو اللي فات موضوع أول شابتر اللي هو descriptive statistics من كل الميجرز اللي فيه measures of central tendency, measures of variation وعلاقاتهم ببعض ونظر في بعض الحالات وكيف تعلمنا الرسمات الجرافس كيف نطلع منهم معلومات وتعلمنا آخر شيء مرتين Chebyshev's equality والempirical rules. خلصنا من هذا الشابتر كامل. شابتر 2 موضوع probability or الاحتمالات اللي تعرفوها. Before we start with probability, we have to know that there are two famous types of experiments in real life. Part of them called deterministic, part is called random experiment. Deterministic like boiling point of water. The water boils at the sea level, of course, at 100 degrees Celsius. So if you keep repeating this experiment any number of trials, you will get the same result. This is called deterministic, and we are not going to deal with this case. It is so simple, needs only a lab to do the experiment. Random experiment that may give you a different outcome each time. You may get the same result or different results. And the most famous model for this experiment, random experiment, tossing a coin. It's tossing a coin. When you toss a coin, you may get the first time head. The second time, it's not necessarily to get head. You may get head or tail. So we will deal in probability with random experiments. If you have any random experiment, you cannot determine exactly what is the next outcome, but you can determine the all possible outcomes. The set of all possible outcomes is called the sample space. The sample space denoted by omega. The sample space is defined as the set of all possible outcomes. For example, if I ask you to find the sample space, for each of the following random experiments. Example number 1. When tossing a fair coin one time. When you toss a fair coin one time, one coin only, you will get either head or tail. So you have two outcomes. The sample space is either head or tail. And we have to know this notation, n of omega means the number of elements in omega. We have here two elements, so the number of elements in omega is 2. Why did I say fair coin, or sometimes they use the expression unbiased? Fair coin, the normal coin you know with heads and tails, with one head and one tail on either side. Gamblers usually have two types of coins, one with head and the other with tail, same faces. If you choose head, he will pick the biased one, unfair one, with two tails and toss it. He will get for sure tail and you will lose in this experiment. So we are dealing with unbiased or fair coins, only fair experiments. Okay, for when tossing a fair coin one time, you will get two outcomes, head or tail. The number of elements is 2. What if we have two coins? Let's say tossing a fair coin 2 times. If you toss 2 coins, you may get on both heads or on both tails. Or the first will give you appear head on the first one and tail on the second one, or the converse, the first is tail and the second is head. We do not have any other case. So we have here 4 outcomes. Either both are heads, or both are tails, or the first is head and the second is tail, and the converse, the first is tail and the second is head. Here, the number of elements in omega is 4. We have 4 outcomes. What if we toss the coin 3 times? Tossing a fair coin 3 times. List all the possible outcomes or find the sample space, the set of all possible outcomes. The 3 coins may give 3 heads or 3 tails, or we may have 2 heads and 1 tail, or 2 tails and 1 head. But you have to consider all the possible outcomes. When we say 2 heads and 1 tail, you have to count all the cases. In this case, we considered the tail to be the last toss, or the last coin. It could be the middle one or the first one. So we have this case, head, tail, head, or tail, head, head. Similarly, for 2 tails and 1 head, it could be tail, head, tail, or head, tail, tail. So n of omega here, the number of elements is 8. And if you can notice the pattern, we toss 1 time, the number of elements is 2 to the power of 1. 2 times, the number of elements in omega is 2 squared. 3 times, it's 2 to the power of 3. So 4 times for sure, it will be 2 to the power of 4. 10 times, we will have 2 to the power of 10 elements in omega. So when tossing a fair coin k times, we have n of omega is equal to 2 to the power of k. Let's change from the coin now. Consider the die. Throwing a fair die 1 time. Die, حجر النرد, الزهر. Tossing a fair coin 1 time, you will get one of the first 6 natural numbers. 1, 2, 3, 4, 5, or 6. So the number of elements is 6, and it is also fair or unbiased. What if we have 2 dice? Throwing 2 fair dice 1 time. In this case, the first die may give 1, 2, 3, 4, 5, or 6. Similarly for the second die, you may get 1, or 2, or 3, or 4, or 5, or 6. So the first die, 1, and on the second die you have also 1, or on the first one, on the second 2, 1 with 3, 1 with 4, 1 with 5, 1 with 6, 2 with 1, 2 with 2, 2 with 3, 2 with 4, 2 with 5, or 2 with 6, and so on until we get 6 with 6. Here we have the number of elements is 36, which is 6 to the power of 2. So when throwing a fair die 1 time, the number of elements will be 6 to the 1. Throwing 2 fair dice 1 time is 6 to the power of 2. 3 dice 6 to the power of 3, and so on. So as a note here, when throwing a fair die k times, we have n of omega will be 6 to the power of k. So tossing a coin or throwing a die or throwing a tetrahedron, the number of elements is the number of elements in 1 toss to the power the number of trials. Okay, this is how to find the sample space, the set of all possible outcomes. Let's consider another example away from tossing coins or dice. Example number 6. If we have a box that contains 4 identical cards, the cards are numbered from 1 to 4. Of course, they are hidden now, but for the purpose of this example, we write them to know the numbers on the cards. If we say that 2 cards are drawn at random, part A with replacement, part B without replacement. Find the sample space in each case. In the first case, you will select 1 card from these 4 cards. It could be 1 or 2 or 3 or 4. If you select, for example, 1 and then you replace it, the second choice, it could be any of these 4, no change on the cards, so it could be 1 or 2 or 3 or 4 also. So you can get 1 with 1, 1 with 2, 1 with 3, 1 with 4, or 2 with 1, 2 with 2, 2 with 3, 2 with 4, 3 with 1, 3 with 2, 3 with 3, 3 with 4, 4 with 1, 4 with 2, 4 with 3, and 4 with 4. So the number of elements here, n of omega is 16. What is the difference between this case and the case when the selection is without replacement? You will select the first card and not replace it in the box, and select a different card in the second trial. Part B, the third choice, it could be any of these 4 cards. You will select one of them randomly. It could be 1 or 2 or 3 or 4. But if the first card you selected is 1 and you will not replace it, you cannot select 1 again. You have to select 2 or 3 or 4. So if the first selection was 1, the second cannot be 1. It could be 2 or 3 or 4. Similarly for 2, if you selected 2 in the first selection and you remove 2 without replacement, you didn't replace it, the second card, it could be 1 or 3 or 4, it cannot be 2. So this case is negligible. So the 2 could be with 1 or with a 3 or with 4. Similarly for 3, could be with 1 or 2 or 3 with 4, but not 3 with 3. You cannot select the 3, not replace it, then select it again, because we have only 1 card, number 3. 4 can be with 1, with 2, with 3, but cannot be with 4. So here the number of elements in omega, the sample space reduced to 12. This idea is similar. In the future we will talk about something called conditional probability. Conditional probability will reduce the size of the sample space, like this case, from 16 to 12, will reduce it. For example, when I say the number of the probability that a student passes this course in the University of Jordan is 90%. So if I meet any student in this course, in the street, for example, in the mall, the probability this will pass the course or the exam in this course is 90%. But what is the probability that this student will pass the exam given that he is from the section 50? So I will not consider all the students in this course to see the ratio of the persons who will pass. I will consider the section 50 only, the students in section 50, and will take the pass the student in this section only. This is similar to what we call later conditional probability. Now, the first definition we took here is the sample space, the set of all possible outcomes. This is the sample space for this experiment. Any part of the sample space is called the event. So, what does the event mean? الحادث. The event is any subset of the sample space. Any point. This this is called event. These two are also represent an event. These four outcomes also can be called an event. Any part of the sample space is called an event. And there are four types of events. Types of events. The first type is called simple or elementary event. Any event consists of only one outcome is called simple or elementary. So this consists of exactly one element of the sample space omega. Exactly one element is called simple or elementary. Two, composite or combined event. When you call the event is composite or combined, if it consists of more than one element, like these two elements or these four elements, together called composite or combined event. So it consists of more than one element of the sample space omega. The third type of event is called the certain event or sure event. Certain or sure event. The event is called certain or sure if it consists of all elements of the sample space omega. All elements. In this experiment, all these elements together, the sample space itself is called sure or certain event. Finally, an event called impossible event or null event. If the event consists of no element of the sample space omega, then it is called impossible or null event. Simply, it is the empty set. Fine. Consider the following example to relate these events, their names, with the outcomes that will appear with us in this example. For example, when throwing a fair die one time, define the following events. And by the way, the event is denoted by a capital letter like A. A represents the event that is defined by getting a number divisible by 5. The event B, getting a prime number. Or event C, getting a number less than 7, and finally D, getting a number more than 6. Find the elements and classify each event above. For this experiment, first of all, we have to know the sample space, the set of all possible outcomes, and we did this before. When throwing a fair die, unbiased die, we will get 1 or 2 or 3 or 4 or 5 or 6. These are the elements of the sample space. These are all the possible outcomes. For event A says you have to get a number divisible by 5. Which of these numbers is divisible by 5? It's only 5. So this event consists of only one element. It is called simple or elementary event. For B, getting a prime number. Which of these numbers is a prime? Prime number that is divisible by 1 and itself only, roughly speaking. And it should be more than 1. Mathematically, this is incorrect definition. But we are not going to talk about number theory here. In simple words, the prime number العدد الأولي اللي بتعرفوه prime number اللي بيقسم على حاله على الواحد بس أكبر من واحد. It's more than 1. So it could be 2 or 3 or 5. The event B consists of more than one element. It is called combined event or composite event. What about C? Getting a number less than 7. Which of these numbers is less than 7? For sure, all of them. This is a sure event or certain event that you would, so sure you will get a number less than 7. The numbers that are less than 7, all of the numbers in the sample space. So this is sure or certain event. حادث أكيد. Sure. For D, getting a number more than 6. No one of these numbers is more than 6, so impossible to get a number less than 6. So we do not have any element more than 6. This is the empty set, or it is denoted by the Greek letter phi. This is called impossible or null event. It is impossible to get a number less than 6 when you throw a third die. These are the types of events. Now we will define the probability of an event. The probability of an event A is defined by the following rule. We will denote it by P of A. Probability of an event A is equal to the number of elements in this event A over the number of elements of omega. It's defined as a ratio. The chance that the elements of A will occur is the ratio between the number of elements in A and the number of elements in omega. For example, in the previous example, we have, in this example, what is the probability of A? Probability of A is equal to the number of elements in A, which is 1, over the number of elements of omega, 6. So the numbers that are divisible by 5, the ratio of the numbers that are divisible by 5, 1 out of 6. This is the meaning of the probability of A. B, the probability of B, we have 3 elements in B. So probability of B is equal to 3 out of 6 or half, 50%. The ratio of prime numbers, B, the prime numbers, the ratio of prime numbers in this set, the prime numbers are half of this set, half of the elements of this set are prime numbers. So it's 50% or half, 3 out of 6. The probability of C, the number of elements of C is 6 over 6, which is 100%. Any certain event or sure event will have a probability of 1. And finally, probability of D, the impossible event, has no elements, it's 0 out of 6, which is equal to 0. For any impossible event or null event, when I say find the probability of a null event or impossible event, the answer is 0. So we have to know the following. First of all, probability of the null event phi is 0. Probability of the sure event, which is omega, the sample space, is 1. And any other event, A, its probability will be between 0 and 1. Cannot exceed 1 and cannot be negative. So any probability for any event must be between 0 and 1, including 0 and 1. And you have to know that the empty set has a probability of 0 and the sample space, all the sample space, will have a probability of 1. راح اكتفي بهذا القدر لليوم كمقدمه للبروبابيلتي. نيكست تايم ان شاء الله راح نبدا مع الرولز اوف probability، ناخذ 7 قوانين ونشتغل عليهم كاملين، وهم اساس البروبابيلتي فيما بعد. لكل ما تبقى من الشابتر 2 راح يكون اعتمادنا على القوانين الجاي السبعه، بس حنبني على موضوع السامبل سبيس، الايفنت، وكيف احسب probability لاي ايفنت. يعطيكم الف عافيه.